Okay, so let's try some data analysis. The theory behind the data analysis questions is completely irrelevant. You're not going to be asked about what the topic is about. You're going to be asked about the results only. So don't feel uncomfortable if you can't remember the topic or it's something that's completely unfamiliar, because that's probably supposed to be the case. Now, if we have a look at this question, it's about interference of monochromatic light. And you can see on your graph that you have two quantities, D and N. Oops. The first thing to do in this kind of question is to really familiarize yourself with the quantities that are being measured. D is the diameter of the rings. So if we have a look, we're looking at the diameter of this circle that's made by these rings, and N is the number. Okay, so you have your first ring, N equals 1 would be that first ring here, and then D2 would be the next ring, and 3, etc. So on the one hand, you don't need to understand at all what the science behind the question is, but you do need to think about the quantities and what they actually stand for. So if you go on to the next question, it asks, firstly, is this a proportional graph? It states specifically, state one piece of evidence that shows that D is not proportional to N. Now this is such a common question, because what it's asking is, what does proportionality mean? Well, proportionality is a straight line which must go through the origin. So, straight line going through the origin. And if we look at this graph, it's very unlikely that it will go through the origin here. So, that is your evidence that it is not proportional. The next thing it asks for is a line of best fit for the data points. Now, it's so tempting to try and draw a line of best fit because it looks like a line. But if you try to include all the uncertainties, it doesn't matter what you do, you always miss some of the points. It's clearly impossible to include all the points by trying to get a straight line through the error bars. And that's what you should always do when you're trying to draw a line of best fit. You must include all the dots, all the points, and your line must go through all the error bars. And if it doesn't, then you need to think about whether it's a line or a curve. In this case, it's actually a curve. And if you try and draw a curve through all the points, you should be able to go through all the error bars. And remember that, you must go through all the error bars. Part C. It is suggested that the relationship between D and N is of the form D equals Cn to the power of P, where C and P are constants. Explain what graph you would plot in order to determine the value of P. Well, this is a very rare question, but does come up occasionally. They want you to use logs. If you take logs of both sides of the equation, log D equals log C plus P log N. Okay, so this is something you must have done in maths by now, and if not, come and see me and I can go through this with you. But you should be able to present this power as a log. Now, what do we do with this monstrosity of an equation? Well, actually, it's quite similar to your line of best fit. If we have D and plot log D on the y-axis, then we're left with M x plus c. A straight line graph will be given if this relationship is in fact the case, or this one better said. If this is definitely equal, then you should get a straight line if you put log n on the x-axis and log d on the y-axis. This gives you a gradient p. Okay, so your gradient will be equal to p, and your intercept would be equal to log c. Okay, so explain what graph you would plot in order to determine the value of p. P would be the gradient if you plot log d on the y-axis and log n on the x-axis, and then p would be the gradient. That's your 3 marks. Now the question completely changes. So the prior information is now irrelevant, really, because it's going to ask you about something else. It says, the theory suggests that p is equal to a half, and so d squared equals kn. Now, if you're worried how this relates to the previous question and all that other information, it doesn't, and it doesn't matter. And it kind of can be a bit scary, but you're going to have to just remember that these questions are about your ability to mess around with results and analyze the data. So don't think too much about what's going on between one section and the other. If we have a look at this graph now, we have d squared against n. The first part, using the graph on page 2, calculate the percentage uncertainty in d squared of the ring n equals 7. Now it's impossible for me to scroll back to that, but if you find on the first graph your value for d when n equals 7 was something like 1.26, but the uncertainty was plus or minus 0.08. Okay, so on your graph, okay, find n equals 7, and the reading for d was 1.26, and the error bar was equal to plus or minus 0.08. So you can go back and check that if you have that in front of you. If that's the first step, you have your uncertainty, and you need to work out your percentage uncertainty. So that'll be 0.08 divided by 1.26 times 100, and that gives you 6.35%. Okay, and I will use the right significant figures, but I'll do that at the end. That's the percentage uncertainty for D. Okay, so I'm still looking at the graph point here, and I'm looking at the percentage uncertainty. For now, d squared, because it's the same as d times d, what I'm going to do is I'm going to add the percentage uncertainties, which will be 6.35 times 2, which gives me 12.7, and of course I need to put that into two significant figures, so that will be 13%. That's your answer. The next question refers to this graph. It asks, what evidence is there that this graph is proportional? So it's asking you the same thing again, effectively. The evidence will be, again, that this graph goes through the origin. So if you follow this line of best fit, bling, it should, do it a bit more carefully, it should be able to, going through all the error bars, bing, go through the origin. So it's a straight line, and it goes through the origin. Both of these things, in fact, if either of these are missing, it's not proportional. The question that follows then also asks you to work out the gradient of this line. Now your read-offs must be clear, and choose read-offs that are more than half the line. So I'm going to choose, assuming this is a straight line through the origin, I'm going to choose the whole area. Again, make sure your read-offs are like using more than half of the line. So here we have more or less, which give you about 2.62. We have a look, and then along here 12. So our gradient will be 2.62 divided by 12, and the answer would be 0.22. Although anything within the range of 0.21 to 0.25 would be considered acceptable. The last question is super easy. It just asks you for the unit of this gradient. This is something that you should always get into the habit of doing. Whenever you work out the gradient, always add the units anyway. But in this case, they're actually giving you extra credit for including them. If you're dividing d squared, which is centimeters squared, by n, which has no units, then the units would be centimeters squared. Okay? So just a few points there to remember. Definition of proportional, a straight line that goes through the origin. Your representation of a log graph when you have a power relationship. And again, if you're not sure about that, please send me an email or come and see me and I'll go through it with you. And then lastly, always use units to work out your gradients. If you have to do an intercept or a gradient calculation, present your data with a unit as well.